So we ended up with Vg magnitude square divided by 8 Rr plus RL, and when you notice that this power dissipated in the resistance is, if you compare this with the power available from the source, if you compare both these equations, for example, now see, look at it clearly, it shows that half of it is being dissipated in the resistance, in the generator resistance, in fact. So I can also say that it is half of the power that is available from the generator, in fact. Okay, so now we need to have a summary of all the powers being calculated. So let me say the power available from the source, let it be P, okay, and then half of this is dissipated in the generator resistance, okay. So this is actually P by 2, in fact, okay. This was the P we got that is available from the generator, and then half of it is dissipated in the generator resistance. And then if you notice, we also calculated, it means that half is gone there, so half is coming here towards the antenna. So half is since this diagram shows half of P is being generated over here, so half is left for antenna, in fact. Now in that case, so the half remaining is, so here we have only P by 2, let it be P by 2, in fact, okay. So let us discuss the summary of transmitting antenna system in the case of maximum power transfer. Initially we had P that is available from the generator, and half of the power was dissipated in the generator resistance. So it means that half of it was delivered to the antenna, in fact. So this was generator, P was the power from generator, and then P by 2 is obviously available for the antenna when it is delivered to the antenna, because half is dissipated over there. So now, and then when half is available, then half half of the power is then again dissipated by the antenna, and half of it is radiated by the antenna, provided we have ECD as well, where ECD shows the antenna efficiency. In a lossless case, in an ideal case, it is equal to 1, okay. So then there is no dissipation. As you can see, 1 minus 1 gives you 0, and this is going to be no dissipation in an ideal case. But here if ECD is if ECD is 1, then that half of the power is being radiated by the antenna. It means that initially we have, for example, 10 watts, then 5 watts is going to be radiated by the antenna, and the rest are actually the losses, and those losses are not the losses of antenna efficiency. In fact, I am considering antenna efficiency at the moment, for example, is equal to 1, then even then the 10 watts is going to get reduced to the 5 watts over here, okay. So what I can say is, with an ideal antenna ECD is where ECD is equal to 1, given maximum power transfer, 1/2 of the power available. So I hope it is now very clear that with an ideal antenna where ECD is equal to 1, given maximum power transfer condition, 1/2 of the power available from the generator is only radiated by the antenna, as we discussed over here. So that's the whole summary of the antenna impedance, and also the impact of the antenna impedance and the maximum power transfer on different powers that are being that is generated and available from the source, and then dissipated in the generator, and then delivered to the antenna, and then after that, with the losses, it reduced to the half. So likewise, we are going to now discuss about the receiving antenna system. As we discussed the transmitting antenna system, their impedances and the impact of impedances and the maximum transfer condition on received and radiated power. And also we discussed the the power available from the generator. Now, as we consider an antenna receiving system, antenna system. So in receiving antenna system, what we can say that, let us draw the block diagram of receiving antenna system, where this VA denotes the voltage of antenna and ZA actually shows the antenna impedance. So in reception mode, we are going to obviously have a wave being coming from outside and it strikes the antenna. So any electromagnetic wave is going to first strike the antenna and then going to go through the transmission line with the characteristic impedance of Z0, for example, and then it is going to get to the load of the receiver. So I can say ZREC, let it be like this, EC. So REC means that we are considering antenna receiver, in fact. So antenna at the moment is acting as generator, okay, where generator is antenna, and then we have transmission line, and then we have the receiver, and this receiver is actually acting as a load for the whole system, right? So assuming that antenna is directly connected to the receiver and there is no transmission line, for example, so we can redraw the circuit and we can say that VA and then ZG, and then we have no transmission line, and then it is attached to the receiver directly. So this point shows the load point, in fact, and this point shows the generator, where antenna is actually the generator, in fact. So in this case, again the same we did previously, that this VA, this ZG can be represented as the combination in a series combination of RR and the loss resistance RL and the antenna reactance JXA, and along which we have the voltage drop of VR and a voltage drop of VL and a voltage drop of Vx, as we considered previously in the transmitting case. And the current I is flowing through this impedance, and then we have obviously the receiver. So for the receiver, obviously we have R resistance of the receiver, and also then we have the reactance of the receiver, for example, and it gets connected to the antenna, in fact. So in this case, if we consider that we again are considering the maximum power transfer condition. In the maximum power transfer condition for the receiver system, so let me write, for a receiver system, maximum power transfer occurs when ZA, where ZA is the antenna impedance, is the complex conjugate of the receiver impedance, in fact. So in this case, we knew that as previously we did the derivations. So RA is actually RR plus RL. This is going to be this should be equal to R receiver, and the reactance of the antenna is going to have to be equal, should be equal to reactance minus the reactance of the receiver, where this shows the complex conjugate in fact. So the circuit current I, so in this case then XA is actually equal to minus XREC in fact, which means that the reactance of the antenna is going to be complex conjugate of the reactance of the receiver. So in this case the circuit current, the current we are talking about is this one, is going to be equal to, so let me write the equation of the current, is actually equal to VA divided by ZG plus ZA in fact,